Bienvenido a este escenario, Dr. Iven Mareels.
Thank you. Thank you for the introduction. So I'm going to talk about climate change challenged agriculture, and I particularly will look at technology. And as you heard, I'm a dean at the Federation University of Australia. I'm also part of the academy in Australia, and I'm also non-executive director of Rubicon Water. Yeah, okay, thank you. And my main message will be that besides infrastructure, civil infrastructure, you also need a digital infrastructure that allows you to measure, so you know what you have, allows you to mine that data, I call that modeling, and then finally manage based on that information. And today I will be focusing specifically on water, the main topic. So measuring water, modeling water, and then also managing water. I'd like to start with saying thank you. Thank you to the organizations that brought me here, which are the organizers. Thank you for ExpoAgua. Thank you also to put water in the context of the United Nations Sustainable Development Goals, because it's actually critical to all of them. Without water, there is no life as we know it. There is nothing that actually can work well. You really have to look after water. And the amount of water we always have had. Nothing has ever changed. And we will not change it, but it's how we use it that is mattering. I want to thank the University of Melbourne because most of my work on water has happened whilst I was dean at the University of Melbourne, and also the company Rubicon Water, which have worked for 27 years. And I wouldn't be able to stand here without significant effort and input from the Australian government, both at the federal level for research and development, but also for support of the company, as well as the state government of Victoria, where the University of Melbourne and Rubicon have their headquarters. It's a real privilege to be able to talk to you about that journey of 27 years. I call it 27 years young because I think there is a lot more to come and a lot more to be done. And I also want to stress the fact that I'm not the only person that has been involved with this. I have just the privilege to talk about it, but this is an effort of many people coming together and working together. So why do I focus on irrigated agriculture? Well, first of all, irrigation is actually the foundation of modern society. It started 5,000 years ago in Mesopotamia. The first cities that were actually able to have a stratified society having different professions besides agriculture. And it was because of agriculture due to irrigation that this was possible, because irrigation took away the uncertainty that existed because of when and where water was available. We do that still today. And I put in brackets flood mitigation, because when the Mesopotamians were thinking about irrigating their land, they also realized that they get flooded quite regularly. And the canals that they built for irrigation were also used to protect their cities from being flooded. Today, 5,000 years later, we are actually using about 50% of all the water from the environment for agriculture in particular. And we provide about 40% of all the world's food and fiber on about 20% of the land. So hence the importance of irrigation, because it gives you that real productivity gain. And the productivity gain has been increasing over the years. However, like you heard already from the minister and the governor and from the ambassador, we need to do more with that same water. We actually have to feed more people that are more affluent, need more food than ever before. We actually have to double food production in the world. And we have very little time to do that. By 2050, we have to actually feed 9 billion, maybe 10 billion people. And there is a concern. Just like I heard already today, 95% of the world's water basins are actually overutilized already today. So we don't have more water, but we have to do much more with food and fiber, and that's where most of our water goes. So with more competition, with urban and industry in general, and having to feed more people, we really have an issue. And the goal, therefore, is that we, in principle, have to double the productivity of our irrigated agriculture. Just to put a bit of context on the map, everything that is red here is already basically in too much stress for being able to work well. Chile is not there too badly at this point in time. But I'll show you in a second that actually you are very close to over-exploiting already. But to put it in the context, United Nations UNESCO World Water Report of last year indicated that 25% of all the land that we use for food is already being affected. 3 billion people on Earth don't actually meet what we call minimum standards for having no water stress. 6% of our GDP has probably already been sacrificed because of our mismanagement of water, if I may say it so. Put in context the droughts and the floods. Droughts cost actually less than floods. Over the last 20 years, the world has at least suffered $600 billion in losses due to floods and about $100 billion due to droughts. And I would say that probably already the demand on water is larger than the sustainable supply that we have available. So that's probably something to let sink in. And we're going to have more competition and we need more water. So you will need infrastructure to build for getting more water. But you don't have a lot of time to build that infrastructure. So your first target, and it's very clearly written down in the World Water Report of 23, but it already has been there since 2003, is efficiency, using water more wisely. You heard from the governor, city of Santiago can lose up to 50% of its water in the pipes. That's not unusual. Most big cities are in the same situation. And also in agriculture, we're in the same situation. So there's a lot of room for efficiency improvement. In fact, we could find 50% of our water if we knew how to address that efficiency. And it's not that easy because we've been on that journey for 5,000 years. So if you haven't solved it in 5,000 years, don't beat yourself up that you haven't solved it in the next 10, but we will have to. The World Water Reports talk all very plainly about management crisis. It's about organizations coming together, in other words, and working together. It's very unusual for diplomatic documents to be talking about crises, but these documents do, and they use the word quite liberally. And the other one that comes out very clearly since 2009 is that actually numbers are a little bit rubbery because we don't measure enough. And we need to know what we have. And we need to know what we have, why, and also to be able to understand it. You can't work without the data. The data are an objective way of bringing people together, as long as they agree on the data, to work through issues, to allow you to know what are the options on the table on how to move forward. Hence my big stress on measure, model, and then manage. Another way of looking at it, this is from a different source. This is the World Resources Institute. They have a prediction what is going to happen by 2040. Anything that is in red is essentially all extracted. And Chile there is in a pretty bad shape by 2040. You're actually making the top 10 of countries that have to deal with water stress. So your urgency is large. It is no different from Australia. The only reason why Australia doesn't make in the black is that it's very large and that the area that you play with plays a role. And then, therefore, they just get a little bit less stress by 2040. But essentially, when you look at the urban areas, we should be just as black as Chile. I'd like to go back a little bit to understanding why we can talk about floods and droughts in the same line almost when we think about water, and why we're seeing more of that happening within the same country at the same time, like happening in Australia with places in drought and places in flood. Same thing here in Chile. Essentially, it has to do with one thing, that the Earth's surface is increasing in temperature. What that means is that water evaporates more easily and goes into the atmosphere. And anything that goes into the atmosphere finally has to come down, so it precipitates back to the Earth. But because the store of water in the atmosphere can't grow, and the store of water on the Earth doesn't grow either, the temperature accelerates the hydrocycle. So things go faster. Same amount of water, but it rotates around more quickly. And what that means is that there is more rain, more intense, and often on shorter periods of time. And as a consequence, there are also more droughts, because the process of how the water falls out of the sky is totally chaotic, meaning we don't know when it's going to happen and where it's going to happen. So you can have at the same time floods and at the same time droughts, because the distribution of how the water evaporates and how it precipitates is totally chaotic, essentially unpredictable. On the short term, maybe a little bit predictable, but not on the long term predictable. On the Earth's surface, just said that, we have groundwater, we have the crops and the plants, and the soil and the lakes and the rivers. They're the main stores we have for water. All of those stores evaporate water. And then, of course, we have the largest store of water of all, which is the oceans. And they evaporate the most. On the Earth, they're connected. Soils essentially store a little bit of water. Plants store a bit of water. Rivers, lakes, they all run off and they come into the ocean. That's how it hangs together. What our problem is that we shouldn't actually be using groundwater, because we can't actually replenish it very effectively unless we spend a lot of energy for it. And our crops and plants need more, and they actually have to do more for less. And there is more competition. So that's the problem we're trying to solve, is to try to have our crops and our plants with less water so that we can cope with all of this. At the same time, we know that it will be harder to cope with the floods and it will be harder to cope with the droughts. So that's an infrastructure issue. So I've talked about the losses in the cities already, and the governor in particular talked about it. It's actually not much better in agriculture. When you look at how the big agriculture systems work, you look at how we distribute water, there is an efficiency of distribution. We take some water out of the dam and it then finally gets to a farm. Well, that finally what gets onto a farm varies quite largely across the world, and these numbers are relatively old. They were 1990 estimates that the International Institute of Land Reclamation and also the United Nations Agriculture Organization produced, but they basically indicate that somewhere around half the water, maybe 60% of the water, is lost in distribution. Not sure how, but it's lost in distribution. And that's roughly what in the 2023 report is used as a standard. 60% is lost between extracting out of the environment and getting to a plant. Now, I say accept these with a grain of salt because we actually don't have real data to be able to substantiate it, except for we know how much water we take out of a dam and we know how much plants and food we grow. And from there we can actually have the overall balance, and that gives you the 60%. But how it happens is not so clear. Australia there is in the green box. That's the number in Australia before we started actually dealing with the automation and dealing with the efficiency of distributing water in Australia. That was around the 30% mark of losses. So I'm going to walk you through how these losses occur roughly and see where the opportunities are for technology to make a difference. We're starting at a dam, and at the dam we're going to extract 100 units of water for food, say. That water gets distributed through channels and finally through irrigation systems on the farm. if we accept the numbers of losses that the World Water Report tells us from 2023, then we have roughly 60% losses, and we have 30 losses, the same amount of losses on the channels as we have on the farm. So 30 units gets lost in transport, 30 units gets lost on the farm. And then finally, 40 units get to the crop. And from those 40 units, a plant through normal photosynthesis methods can store 1% into what we then call food or fiber. The opportunities, lack of measurement. We don't know much about how this system actually works from the measurement point of view. This was a Dietrich wheel invention, 1907 in Australia, an alumnus actually from the University of Melbourne. It was used a lot to tell at least the farmers an idea of how much water they were using. But if it's in that particular condition, and I've taken not a standard picture, but a bad picture, I can assure you that that wheel doesn't turn the way it should turn and tell you how much water goes on the farm. I also have found frozen fish, by the way, in Australia in these wheels. So, what is the problem with distribution? Well, distribution typically works on how much water the farmer needs, and I will take some water out of the dam. I actually don't think about how much water is in the channels. That is a big issue. That means also that there is often an inequity between upstream and downstream. The people that are very far from the dam get less water than the ones that can take it first. There's a visibility lack. We don't know actually what we have in storage. We typically work manually, means that the adjustments we can make to the flows along the channels is very infrequent, maybe once a week, once a day. Planning is hard in that context. Most of the irrigation systems work on scheduling. So you get a schedule for a particular crop. It's not done on demand. It's not aligned with the physiology of the plant or the crop that you're actually growing, but just accordance to what you will need roughly to be able to make that crop work. It's not very precise when it actually happens, when it starts, when it stops. You don't exactly know how much volume water you get, nor how much your flow is that you're getting. Often it's difficult to maintain a particular water level. Water level is a quality of service, by the way, in irrigation, because it determines how much land you can command, because all you have is gravity. All you have is potential energy to play with. So water levels actually make a big difference. On the farm, we have similar problems. We have too much water, then it runs out at the back. We call that runoff drainage problems. And with drainage, if there is too much water runoff, we also lose fertilizers, so it costs the farmer twice. He pays for the water he didn't use, and he pays for the fertilizer he lost. If there is too much water, we also seep water away. And by that I mean is that the water will go beyond the root zone and not available anymore for the plants to be used, seepage. And because we're not getting the water when the plants actually need it, the plants themselves are quite wasteful. They can't actually use it properly. I will talk about the red boxes, but there is also a lot we can do on how actually plants use water. There's a lot to do with genetic modifications that allow you to have crops that are more drought resistant, crops that give you more yield, crops that are also more pest resistant, or use less fertilizer. All of those things matter, and we should all work on all of them. My work has been interested in how do we actually distribute the water? Can we measure it? Can we address these issues that are happening in normal irrigation systems? And they have been happening in irrigation systems since the Sumerians, by the way. Even the Code of Hammurabi described ways of how to do this 3,000 years before Christ. So one happy thing about this is that there's a lot of room to improve and to do better. That makes it an interesting object. And there's a lot that we can do with the existing infrastructure if we can just make it work harder a bit. And that's what efficiency is all about. Not new infrastructure, but upgrading that infrastructure with an overlay of digital information that allows you to work it better and harder and get you better efficiency. So, if you start doing that and you automate all of these processes, there's a lot you can gain by providing it as a cyber-physical system. A system that measures the water, actuates the water, on demand, and where the demand, in my opinion, should come from the plants themselves and not from the farmers. And our farmers don't like me saying that, but in fact, the plants know more about being thirsty than we do, that they do know about being thirsty. So if we could listen to the plants when they are thirsty and give them water when they need it, when they need to grow, that's actually the best way of doing things. By automating this, by measuring where this water is, you can actually save an awful lot. Instead of having 100 units released and having 40 units arriving at the plant, you can actually get to 70 to 80 units at the plant. So you can double the productivity on the farm with the same amount of water. Alternatively, you could say, well, I can grow my same crops with half the water. That's the political question. That's the question the society has to solve. Technology is not going to answer that question for you. It gives you the options. The options on the table are different from the past because of technology. That's where technology helps. But coming to an agreement of how you use water is a governance issue. It's the use of how you want to use the water. That's not answered by technology. So by using the channels and what's stored in the channel, you can actually make what is looking like a gravity-fed system work on demand. Just like you open a tap at home and you get water coming out of the tap because the water is pressurized, it comes at you very quickly. You can get very, very close to that type of scenario, even in a gravity-fed irrigation where you only use the gravitational strength to pull the water through the system. You do that in a dynamic way. That's why you need quite a bit of measurements, because storage changes all the time. There is no such thing as steady state on the channels. Once you start measuring, though, you can also answer the question about equity. Does the farmer at the bottom end get the water that they actually deserve to get? Is it equitably distributed across the channel in the way that society has said what equity means? It's also more accountable because as we measure it, we actually know where the water went, where it dissipated, and it allows you to do some long-term planning as to the effectiveness of what those channels can and can't do, or where you remediate, for example. That comes clear from that knowledge. By being on demand, is when you actually need the water for the plants, you get more precision. And you get precision in all aspects. The total amount of water you've ordered, when you get it, when you don't want it anymore, and how fast you want it, and at what level you want it, which makes the life of the farmer much better because all the uncertainty of irrigation is now taken away from them, and is they given water as they need it, and in fact, if they can do it, as the plant needs it, which is about the best you can get. The flow-on effects of getting the water at the right time for the farmer and for the plants in particular are actually significant. And most of the units that you gain on the farm are due to the channels being responsive to what the farm needs. And hence, you get about a 40 to a 60% improvement on the farm by just being there on time with the water and not giving too much water, not having the runoff, not having the loss of fertilizer. All of those things come into play when you can do on demand and accurate. So this gives you the gains that you can achieve. So you can indeed cut all the losses by more than half. My dream, I've already talked a little bit about it, is that the plants in the end are the ones that need the water, so therefore the plants should decide when to need the water. And that means that you instrument your farm as well. And it's basically independent of how that farm is actually operating, whether you use flood irrigation or drip irrigation or sprinkler systems. All of those modalities have a place on the farm, and the farmers have already invested a lot in making their farms more effective. What they are lacking is the water on time in the quantity they needed. And that's where the efficiency gain of the canal automation comes into play. But in principle, if the plants, and we have experimental sites that work like that, the plants tell me when they're hungry, the farmer can set up rules of when and when they buy water and how they buy water, then the system can actually set up the entire delivery from the dam all the way to the farm and the sprinklers on the farm to deliver that water precisely as the plants need it. That's the gain of automation. More crop per drop. and you can work within your supply limits. So this becomes much more drought resistant. And with a little bit of imagination, you can also use that same system to also get rid of floods, because there are a lot of irrigation channels that you can use, and if you automate them, you can actually push water through those systems at a very high rate, and therefore also do flood mitigation. That's work for later. This information loop is an actual enablement of measure, model, manage in closed loop. I call it an information loop because the information flows in the loop essentially, and it allows everybody along the line to understand what actually has happened with the system at their level of interest. The farmer gets a view of what this farm is doing. In principle, they know what the paddock is doing, they know how they order the water, they know when they get it, etc. They can really start planning the crops that they can have. In fact, in many places in Australia, people are now putting 3 crops where they also only had 2 crops, because they knew exactly how much water there was left in the ground so that they can put a 3rd crop into place. From a channel management point of view, really important, because the information you get from the channels will tell you which channels seep more, which channels get water stolen, which channels are getting damaged. And so you can direct your infrastructure money much more carefully to those channels that actually need it. And what we typically found is that 20% of our channels cause 80% of our troubles. So therefore, you can really direct that infrastructure much more carefully. Having this system work like that, we call it a cyber-physical system. You could also call it an Internet of Things, but it's all information for water management, specifically focused on agriculture, but combine that with what you have for industry, combine that with IoT from industry for the city, you start building an infrastructure that actually looks at water holistically. That's the point I'd like to make. In summary, irrigated agriculture is essential to our society, and we'll need more of our irrigated agriculture than ever before. In fact, they will have to do 50% more than what they have done in the past. Our water is not in short supply, it's just economically limited. And that's probably the whamming that we get at this point in time, it's subject to climate change. Every degree that the temperature rises in the atmosphere or in the surface will give us 5 to 10% acceleration of the hydro cycle. We are at this point in time heading for 3.7 degrees centigrade climate change. That's a hydro cycle roughly 25% faster than what we have now. That's much more floods than we have seen ever, and much more droughts than we have seen ever. Not a pleasant scenario to be at. We have to address that. At the same time, we'll have to work with water to make that work in those circumstances. Climate mitigation, in a way, is really important, and without water, the society doesn't work. So hence, it behooves us to think what happens if we don't make our climate targets, and everything basically tells us that we are not. We have to do something about how we use water. In the end, all our communities come together. Cities, agriculture, industry. We all use water, very different quantities, 70% in agriculture, roughly 15% in industry, 50% in the cities. It varies a little bit from where you live, but that's the average across the world. Sitting at the same table, understanding what the values that each brings and why. And you heard from Barcelona, actually water is also very important for tourism, for the environment, for our health, our well-being. How do we have that conversation? And you can't have that conversation just with intuitive information. You have to have that conversation with hard information, particularly because you're working close to the limits of what we can do. It's not like you have lots of available to go around with it. Equity, accountability, efficiency are the words that I would stress at this point in time, because they are your shortest time options. Infrastructure takes a lot more time. You're looking at decades. This infrastructure, digital infrastructure, you can implement now, and you can start using now. You can start now using with efficiency. And in fact, the first response for drought response in cities is always restrict the water use. That's the easiest thing to do. Well, with this thing, you can do this much more cleverly. Information-based water management. Water on demand, as you need it, not when you don't need it. Keep as much water in the dam. That's the whole point. Keep your reserves high. That's the thing that we want to achieve. And you want to do this with as much water in the reserve bank as you can, because you don't know how long the next drought will be. We had 20 years of drought in Australia, not unreasonable, but the next one maybe 30 years. We will actually run out of water if we weren't prepared for doing that. But we are preparing for it, and I hope that everybody here also is preparing for it, because those things are going to happen. Thank you.
Un, dos, tres. Ahí
Yeah.
sí.
Yes,
Yeah.
you're wrong.
How are you?
Thank you. Less nervous.
There's great. There's no water to lose and there's no time to lose. I've been told that we have to rush forward with our time. Well, 10 minutes.
10 minutes,
Great.
yeah. Thank you. Thank you.
Thank you. So, good morning, everybody. Well, the idea of this part of the morning is to just have a chat, maybe try to go into more depth.
Oh, I have some questions.
Maybe answer some questions. I don't know if we have a system to answer questions from the audience, but I have a question of myself, and then maybe we can move forward. Ah, you need that one.
Okay, yeah.
Okay, there we go. So I really like your talk
Thank you.
Your presentation. And I think it really ties very well with what the previous presenters and the people that gave their greetings in the morning were talking about. Because in those presentations and the words that we heard, the word technology did not come up so much.
No.
And the words that came up more were about governance, about getting together people, and then agreeing on things. And I have many questions, but one phrase that you said struck me, because you said technology will not tell us how to use water. But and I would like to push you a little bit on that for the audience benefit, because you have worked in innovation as well. And we've seen once and again in other rounds of innovation that technology does change the way people behave. And I would argue that it may be also a vehicle for changing how people make decisions in a way.
Oh, yeah, absolutely. So, okay, I maybe have given the wrong impression. Technology gives you more options. It doesn't tell you which options to choose. So you're absolutely right. Behavior will change. If I have a much more efficient system, I could be very selfish and say, okay, I will use the water that I have a right on, and therefore put it all back into my plants because that's money in my pocket. I've optimized for my own self. That's the option technology gives me. But from a society point of view, the option may be far better to say, actually, if you save 50% of your water, I would like to use that for my city because that city is running out of water. And that's 8 million people or 10 million people that you now can actually sustain with water. That option the farmer doesn't necessarily see as his option or her option, but society can see that option. And so that's the question that I want to put on the table, is that you have more options to choose from, you have more freedom to move, but where you move in technology depends on the constraints you put and the governance you're going to put over it. So I do see there is a place for both. I'm not surprised that the minister talks about civil infrastructure. I'm not surprised the governor talks about governance. That's closest to their heart. For me, technology is closest to my heart. So I talk about how can I help these people? How can I make a difference for society? And I can make a difference to society by giving you the technology with the most options. If technology constrains you, you have to live with it because I can't do better. But if I can give you more options, that's what I like to do. So I think that the technology, the digital infrastructure you built for water management provides more options for all participants, and it will change behavior. If it didn't, it would be a shame.
Thank you. Thank you. And regarding this, when we talk about the participants, we discussed government, water users, agencies, enterprises. Would you be able to share with us maybe examples of how these partnerships may have come to pass in cases that you know about and mediated through technology in a way?
Okay, right. Partnerships are important. As a university professor, you can think about beautiful things and you make beautiful papers and people cite you, and that's one way of getting recognition. But if you want to do something for society, then that is not enough. Society then has to know what the technology is, what these ideas are, and that requires a totally different type of conversation. It's a conversation you can't have by yourself. You have to have other people helping you in that, doing that. And if you then want really to make a change, impact it, then you need industry and government to come on board and say, yes, we're going to invest and we're going to take the risk out of this and make it more feasible. So those partnerships come very natural in an innovation cycle. And innovation often is happening in a situation where there is need. Necessity is the mother of invention, we say in English, right? So necessity in Australia is obvious. Not enough water to go around. So how can we use the water we have better? And the question is, what water do we really have? We didn't even know how to answer that question. So you have to put infrastructure in place. You have to work with the people that want to have all of that information. And then start explaining, because technology always has a hurdle. Data don't mean anything to people that are not dedicated to interpret the data. It's a very asymmetric environment. So education is very important. Universities can help with that. But then actually putting that education into practice, governance, communication, then implementation, and then you have to see people appreciate technology. I am happy when you show me a computer simulation. Most people think, so what? But seeing it in action, knowing that I could show a video of a farmer says, you've given me 10 years on my farm, and I can do it now all by myself. And I can do it from the comfort of my living room. 10 years on my farm means a lot to me. I was going to retire when I was 60. I'm going to retire when I'm 70. That is real impact for real people. Or see a smile in India of a farmer that said, I had a farm on the bottom of the channel. In 40 years, my farm has never seen water. And your system brought the water here. First time in 40 years. Now, that smile pays for every anxiety and every minister and everybody I work with ever, and for everybody involved. It is really exciting to see that difference. So that gives me a kick, although I do like the maths.
Well, thank you very much. I think I'm looking at the watch, and I think we have to wrap up because the session has to move on to the next stages. So I ask the audience to give a round of applause for Iven, please. And thank you for your presentation and your visit.
If people want to ask any questions later from me, I'll be available. I'll be more than happy to interact. Forgive me, I do not speak Spanish.
Okay. All right. So thank you. We're